Hello everybody. This recording will deal with the tnc-x and I'll just start writing this down, and there's plenty of sites on the web, and you can look it up, and there's plenty of explanations and schematics and things, and we deploy this in our schematics. So let's just in general go over what happens, and let's in particular take up the receive section first. So the first thing we have is we have an audio signal that comes in here. And just as a reminder that there are two tones on this thing. One is 1200 hertz and the other is 2200 hertz. And ones and zeros are represented by these two tones, and the frequencies of these two tones. The first thing that comes through is a filter. We just filter off some of the noise, and then we come into a modem chip, and in this design we have picked an MX614. So audio comes in here, we filter it, take a little of the noise out, and the audio appears here. Now, what comes out of this thing is that these tones are now converted from tones to data. So a 1200 hertz tone may be represented as 0, and a 1200 and a 2200 hertz tone may be represented as a 1. So this is the this is the receive portion. This goes to a pick, which is a 16F 628 flavor, and out of this comes formatted data. All right, now the data is formatted in packets, and in our satellite we run this in what's called the KISS mode. So the packets, the over-the-air packets, would look something like this. And a packet is just a group of bytes that are grouped together in a special sequence, which we call a protocol. And the protocol is an AX.25. And if you Google that on the internet, there's plenty of resources on there. But in very simple terms, a packet being a group of bytes, and the first thing that's sent is a starter frame, or framing bits, and you can send a few of these things, right? And then in the so over the air we see framing bits, and then we see the data payload. And then we put error checking, or CRC, on this guy. So if we were to tune in over there, we'd see framing bits, we'd see data payload, we'd see the CRC. So here's what happens in code, and the source code is available on the internet. But typically, if we were sending data out, the deal is that this device here wants to see all of the data sent to it, starting with a C0, then comes the payload, and you end with a C0. Now the C0s are significant because when this thing detects a C0, it turns on the transmitter, and when it sees the second 0, it turns it off. Now I'm going to because of the time frame, and I don't have that long on this deal, I'm going to really talk about the receive data. So what we see out here is that over the air comes these framing bits, these payloads in the CRC. What actually gets passed on past this thing is the payload. Now, if there's some errors that that take place along the way, and this thing picks up errors, it does not put out any data. So just kind of sort of an overall review, and I know this is complicated, you may have to go through this a few times, is that tones, audio tones come in here from the receiver. They're filtered out. This thing converts the tones into ones and zeros, and this formats it, this PIC here formats it into the AX.25 protocol. And the subsection of that is in the KISS mode, where just the payload appears. One other further complicating factor is that the first few bytes in the payload are bit shifted. So if you were to sniff these bits coming out, the first I think 8 to 10 bytes are look like garbage. They're actually bit shifted. You actually have to go shift over bytes to decode those things. Now, different X25 packets have different sequencing of the bytes in here, but in our satellite we are using the KISS mode, where basically the payload, whatever goes in the payload comes out. So let me stop this video here, and what we will do is then we will look at the schematic and try to look schematically what's happening. So so long till the next video.